Hello everyone, myself Prabhas Singh, Assistant Professor from ABES Engineering College, Ghaziabad. In this lecture, we will discuss about what is branch and bound, how it is different from the backtracking, and we will try to solve one problem, that is traveling salesman using branch and bound technique. Initially, we will discuss about what exactly is the definition behind the branch and bound. It is used for solving optimization problems. It solves the problems relatively quickly. More or less, branch and bound follows the same approach as the backtracking. That is, it tries out all the possible sequences. But backtracking follows a DFS approach, whereas branch and bound follows a BFS approach. While using a BFS approach, it will solve the problems quickly. Moving ahead, what exactly is a TSP problem? Traveling salesman. Traveling salesman is a problem where we are given n cities and a salesman need to visit these n cities in such a manner, starting from any city, he must visit all the cities and comes back to the particular city from where he started with a minimum cost. We used to solve this problem using a greedy approach, dynamic programming approach, and now the branch and bound approach. In a greedy approach, what we will do, we will traverse the city on the basis of the minimum cost. Let's suppose while traversing from H1 to H2 city, there are multiple paths, but what we will do is, as we are following a greedy approach, we will pick up the minimum city and keep on traversing with a minimum approach. But is it confirmed that traversing a minimum city will lead us to an optimized solution? That we will try to figure out using a branch and bound approach. Now, what exactly the statement is, a salesman need to visit every city exactly once. He has to come back to our original city from where he started the journey, and what is the possible route that is shortest to cover all the cities. This is one of the example we have taken at 4 cities example. And we simply, if we use this with a greedy approach, we are getting it a solution of 80. But now what we will do in our branch and bound, and how we will traverse all the cities in order to get an optimized solution. Now, this is a initial cost matrix for a graph given to us in a previous slide. What we have done is, if there is an edge from A to B, we simply represented that weight. If there is no edge, then we simply represent it as infinities. So what we have done is step number 1, while preparing a cost matrix. If there is an edge, we simply write its weight. And if there is no edge, we simply write it as infinity for a given graph. Now, how we will proceed? What we will do is, we first have to calculate the cost of a live node or the root node. In this journey, what we will do, we will first perform a row reduction and then perform a column reduction. Now, what exactly is the meaning of row reduction and column reduction? What we will do is, we will see the minimum of this in this row is 4. We will subtract 4 from each of them. It will be 0, 8, and 3. Then minimum is 5. Then minimum is 6. Then minimum is 2. Then we get a reduced matrix after a row reduction. It helps us to ensure that every row is carrying a minimum value as 0. After performing the row reduction, we will perform a column reduction. Let's explore this one by one. Now, this is row reduction. Objective is we have a 0 in each row. So what we will do is we simply reduce 4, then 5, then 6, then 2. We will get 17 as a cost of row reduction. And after row reduction, we will be getting this matrix. This is an improved matrix or the reduced matrix if we talk about this. Minus 4 will lead us to 0, 8, 3. Then this will lead us to 0 and 13. This will lead us to 0 and 5. And this will give us to 8, 0 and 1. And we get this matrix. So this is the first step what we have performed is a row reduction. So as of now, what we will proceed towards a solution. We are given a graph. Then we represent it with the help of the cost matrix. If there is an edge, we simply write a weight. If there is no edge, we simply write it infinity. Then first step is to perform a row reduction. That is, we want 0 in every row. During this journey, what we have to do, we have to subtract a minimum value of this process. Right? After performing the row reduction, then we will perform a column reduction with the same objective of getting 0 against everything. So how we have done is, if we see this, we have 0 in this, we have 0 in this, we do not have 0 in this, we have 0 in this. So what we will be do? We will be reducing this by this. So this 17 plus 1 will be giving us 18 as a cost of the root node or the live node. And the optimized matrix will be this only. This was 8 and 1 in the previous one, and this is a reduced matrix. And what we are getting is 18 as a cost. So as of now, what we have done is we are given a graph. We have simply created a cost adjacency matrix. If there is an edge, we simply write a weight. If there is no edge, we simply write as an infinity. Then we perform 2 steps, row reduction and then column reduction. What is a logic behind a row reduction? We must require 1 0 in every row. We pick the minimum element of the row and subtract all the elements from that. We keep on this with an objective of every row must contain a 0. We get an optimized matrix or a reduced matrix. Then we apply a column reduction on this with an objective of having 0 against every column. We keep on doing this and we get a reduced matrix as this and the reduced cost as 18. After reaching this, what has happened is initially we are at a node 1 and the cost of this is 18. Now there can be path of going to cost 2, then 3, then 4. If we talk about a specific, let it be A. The cost of A is 18. Why? What is the meaning behind the cost of A? This 18 is representing that there was a possibility to start the journey from A, B, C, D. But if we start the journey with A, we will be getting a minimum cost as 18 if all the paths will go in a extreme opposite direction. After going through A, we can go to B, we can go to C, then we can go to D. Now in DFS, what we were doing, we keep on exploring this. But in BFS, we keep on exploring like this. So what we will do, first we will see a path from A to B. During this journey, what we will do is we were given a matrix, that is this A wala matrix, and we keep on doing the work on this. First step is row A as infinity and column B as infinity. What is the reason behind this? Row A as infinity and column B as infinity, because what is happening in row A? A is behaving as a source. And what is happening in column B? B is behaving as a destination. So what we will do, this row and this column is made as infinity. Then next step is What B2, make B2A as infinity. Simply let's see that A to B is given. We done A row as infinity and column as infinity. Simply B2A as infinity. Why B2A as infinity? We have done B2A as infinity with an objective that cycle must not be formed here. Because in TSP we have to visit all cities, then we come back to A. As of now, we have gone to A to B and then B to A, then there is a cycle, then they do not suffice the purpose of the TSP problem. So the next cost will be what? Everything will be infinity in this. We have done row as infinity, we have done column as infinity, then B to A as infinity. These are the updates we have done here. After doing this, what will be the cost? Now we will perform a row reduction in this. Row reduction 13 minus. If we perform column reduction, if we do row reduction, we will get 0 here. Then 0, then 0, then 0, then 0. Then we will do column reduction. We will get 0 and 3 here. So the total cost of A to B will be cost of A, that is 18. Then what is the cost of A to B? A to B is 0 plus this 13 plus 5 will be giving us 18 plus 18, that is 36. That is, we will get 36 here. Right? We can see this. This was a process of row reduction, and this was a process of column reduction. And where we get a cost? 18. That was the original cost of A. Then this is row reduction and column reduction cost 18, and 0 is what we are carrying from A to B. Now, if we talk about the path from A to C, what will be the thought process? Consider A matrix. Then make A row as infinity and make C column as infinity. That is this. That. Because A and C are behaving as a source and the destination, then make C comma A as infinity. That is. After doing this, then we see that there exists 0 in every row or column. Yes, done, 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 and done, 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 and done. Hence, the cost of A to C will be 18, the cost of A. Row reduction, column reduction, 0. Done. Then what is the cost from A to C? That A to C wala cost is 7. That we can see in an initial graph, this A to C. So this will lead us to 25. Now, what we are getting is A is 18, then B is 36, then C is 25. Now we will explore D. Now, during this exploration, what we will be doing? What is the cost of M, A, comma, D? This, let's suppose this. What is the cost is? 3. So now what we will do? Make this row. Done, infinity. Make this column. Done as infinity. Make this to this path. Done as infinity. After doing this, then see, is every row carries a minimum value? This is okay. All are infinities. This is okay. This do not carry. So what is 5? Then it will be 0. This carries okay. If we talk about the column, zeros, 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 and zeros. So what will be the cost is 18. Done. 5 is a row reduction cost. Column reduction cost is 0. Plus 3 is a path cost from this to this, A to D. That is 26. And this is a reduced matrix. After calculating this, we get a cost as 26. And here we are representing a path A to B is 36, A to C is 25, and A to D is 26. Now we will explore this path of what? A defining B, C, D. Now we will explore C. That can be what is B and D. During this exploration, what we will do is we will have a matrix of this. Moving ahead, if we talk about ACB. Now, during this journey of ACB, what we will have? C, comma B cost, done. Then C row and column B, done. And then we have B, comma A as infinity. Now, what is the logic behind B, comma A? B, comma A means that ACBA should not be the path. We must explore D. Right? So what we will do is we simply carry this value as infinity. Make column C as infinity. Sorry, row C as infinity. Then column B as infinity. After doing this, what we will do, C, comma B as infinity. And then we will see a row reduction and column reduction in this. And after doing this, what we will get is 13 from here and 8 from here. That will be 25 plus 13 plus 8 plus infinity. It will be carrying infinity, means there is no solution exist from this. Then we explore another possibility, ACD. Now what we will be doing here is ACD, CD is 0. If we talk about this CD is carrying 0. CD is carrying 0. What we have done is C row, D column, then D, comma A as infinity. After doing this okay, this okay, this done, same cheese, this, and this. Now what happened is 25 plus 0, no row reduction, no column reduction, and 0 for that, what we get is CD. That is 25. As of now, where we get is A, then we are getting it B, C, D. Then going through this path, we were having this B and then D. Now we are at this path. And now D goes to B. Next will be A, C, D, B. And what we will do in this is, we will have D, comma B cost. Whatever. What is D, comma B cost? D, comma B is 0. That is 0. What we will do, make this row and this column as infinity. Make this path as infinity. And after doing this, we will perform the row reduction and column reduction. And then doing the row reduction and column reduction, it will be giving us simply zeros. 25, 0, 0, and 25. That is 25 units. This will be the solution which we have obtained as A, B, C, D, then B, then D, then again B. So what we are doing is, this is 18, this is 26, sorry, 36, this is 25, then this is 26. This was infinity, this was 25, then this was again 25. This was a path which we have obtained. Thank you.